In this video, let me consider one numerical on Laplace transform. Find Laplace transform of the waveform shown below. This is the given waveform. We need to find Laplace transform of this waveform. So here in this waveform, we can observe that at t equal to 0, there is one ramp signal, and this ramp signal is stopped at t equal to t. So the first signal is ramp signal. Let me divide this v of t into different sub signals. I will take the first signal as a ramp signal. I will represent it as f1 of t. Let my f1 of t is a ramp signal. So this is say f1 of t, which is a ramp signal, begins at t equal to 0. So this is the ramp signal. So this will continue till infinity. Let me represent this ramp signal as, let me calculate the slope of the signal. So this, I can say this is t here, and here we have v. So the slope of this signal is v by t. Let me represent this f1 of t as, that is f1 of t is equal to, slope is v by t, and it's a ramp signal. I can represent it as t u of t. Now here we can observe that this ramp signal is continued till infinity, but here in a waveform, this signal is stopped at t equal to t. So to stop this ramp signal at t equal to t, we should add one negative ramp signal at this t equal to t, which should be like this. So let me add one negative ramp signal at t equal to t. Let that be my second signal, that is f2 of t. So my f2 of t is, say this is f2 of t. So at t equal to t, one negative ramp should come. So this is a negative ramp signal. So its slope is same, that is minus v by t. Let me represent this f2 of t as, that is f2 of t is equal to, slope is minus v by t. So it is begins at t equal to t. So it is shifted ramp signal, shifted by unit t. We can represent it as t minus t u of t minus t. So when a positive ramp signal is added with negative ramp signal, the resultant signal will be like this. This will be the resultant signal. This will be the resultant signal. When we add f1 of t with f2 of t, the resultant signal will be like this. But here we can observe that at t equal to 2t, there is one step signal, that is its voltage or its value is increased from V to 2V. So we should add one step signal of magnitude V at t equal to 2t. Let that be my third signal, that is f3 of t. So let me write f3 of t. So say this is f3 of t, that is at t equal to 2t, we should add one step signal of magnitude v. So its magnitude is v. So already at t equal to 2t, the magnitude is v. When we add this one, it will become v plus v, that is 2v. So we will reach this point. So I can represent f3 of t as, that is f3 of t is equal to, it's a shifted step signal, shifted by unit 2t. I can represent it as, here magnitude is v, that is v u of t minus 2t. So now I will show you what happens when we add f1 of t, f2 of t and f3 of t. So upon adding f1 of t, f2 of t, f3 of t, this signal we will get. So this is f1 of t. Upon adding f2 of t, we will get this signal, and upon adding f3 of t, the signal will be like this. But here we can observe that in original signal at t equal to 2t, there is one negative ramp signal which begins at t equal to 2t. Let that be my fourth signal, that is f4 of t. So the f4 of t must be this is f4 of t. It must be a negative ramp signal begins at t equal to 2t. That is, say this is 2t, and here we can see that it must be like this. So here let me calculate the slope. So at this point, let me call this is x1 y1. This point is say x2 y2. Here x1 is 2t, this is 2t, y1 is 2v, and here x2 is 0, sorry, x2 is 4t, and y2 is 0. Let me calculate the slope. That is, here slope will be, we know that slope can be calculated as y2 minus y1 divided by x2 minus x1. So y2 is 0 minus y1. y1 is 2v, and here x2 is 4t, and x1 is 2t minus 2t. Or I can write slope is equal to minus 2v by 4t minus 2t is 2t, that is nothing but minus v by t. So slope of this is minus v by t. So therefore the slope of this will be minus v by t. So let me represent f4 of t as, that is, f4 of t is nothing but shifted ramp signal shifted by 2 unit. So it will be minus v by t, t minus 2t, u of t minus 2t. So now upon adding the negative ramp signal, the signal will be like this. Now the resultant signal will be like this. It will be continued till infinity. But here we can observe that at t equal to 4t, this negative ramp signal should be stopped. To stop this negative ramp signal at t equal to 4t, we should add on positive ramp signal at t equal to 4t. So let that be my next signal. So my fi of t will be positive ramp signal begins at t equal to 4t. That is, say this is t, say this is fi of t. At t equal to 4t, we must add one positive ramp signal of magnitude same, that is minus v by t. So therefore I can write fi of t is equal to minus, that is plus v by t, t minus, it begins at t equal to 4t, t minus 4t, u of t minus 4t. So therefore now we can write the given waveform v of t is equal to f1 of t plus f2 of t plus f3 of t plus f4 of t plus f5 of t. Or I can write v of t is equal to, we have f1 of t is v by t, tu of t, v by t, tu of t, f2 of t is minus v by t, minus v by t, we have t minus t, u of t minus t, t minus t, u of t minus t. Next one is f3 of t. So f3 of t is v u of t minus 2t, that is plus v u of t minus 2t. Next one is f4 of t, which is minus v by t, minus v by t, t minus 2t, u of t minus 2t. Finally we have fi of t, that is plus v by t, t minus 4t, u of t minus 4t. Now let me take the Laplace transform of this v of t, that is taking Laplace transform of v of t, we get, So Laplace transform of v of t is, we have v of s is equal to Laplace transform of this is v by t, tu of t, that is ramp signal, 1 over s square minus, we have constant, that is minus v by t. This is shifted ramp signal, shifted by unit t. So it will be v by t 1 over s square e power minus t s, and for this plus, this is the step signal, that is v by s e power minus 2ts, that is shifted step signal, and here we have minus v by t, again it is shifted ramp signal shifted by 2t, that is into 1 by s square e power minus 2ts, and finally we have plus v by t shifted by 4t, that is into 1 over s square e power minus 4ts, or I can write v of s is equal to, let me take v of t 1 by s square common, that is v by t 1 over s square, we have 1 minus, here it is v by t, and here it is 1 by s square, that is e power minus st, plus here we have v, that is taken out, and there is s will get cancelled. I'll take ts e power minus 2s minus v by t 1 over s square, that is e power minus 2ts, plus here this term is same, that is e power minus 4ts. So this is the Laplace transform of given waveform. Thank you for watching.